In this video, we're going to figure out what the number e is as a limit. So pretty much, e is equal to the limit of what? What is the number e as a limit? Now, we already know where the number e comes from. It comes from the fact that pretty much, e has to do with the exponential functions, and for e to the x, if we were to take the derivative of e to the x, we know that that's just going to equal that same exponential function, e to the x. And we know that this is based off the idea that the limit as h approaches 0 of e to the h minus 1 over h equals 1. It's because of this limit that for this specific exponential function, the derivative will result in itself. And we saw this idea in the previous video. Or pretty much the previous video was, where does the number e come from? And we came up with this idea. And I'll put a video link in the description below if you want to see that. Okay, now we're going to use this idea to figure out what the number e is as a limit. So how do we do that? How do we go from here to figuring out what e is as a limit? Well, the first thing is, we probably shouldn't have the number e here inside the actual limit itself, right? We don't want e inside the limit. We want e to be equal to the limit. So we probably want to get rid of this e somehow. So to do that, what we could do is we could substitute this top part of the equation for something else. For example, we could say that some other variable u is equal to the top part of the equation, or top part of the expression, like that. Now, if we substitute the top part of the expression for something, we're going to need to substitute this for something. And the reason why is because we're pretty much substituting this h for something else in its place. And our limit depends on h, right? So we're going to have to substitute this h for something in terms of u as well. And so what I'm going to do is I'm just going to solve for h. H is equal to the natural log of 1 plus u. And so we can just substitute these two things into here. And so what we get is the limit as h approaches 0. Actually, no, it's not going to be h approaches 0, but we're going to change this to u because we're substituting everything in terms of u now. Pretty much what our fraction right here is going to be. Remember, e to the h minus 1, it's equal to u, so we're going to replace it with u. And h is equal to natural log of 1 plus u. So that's what we get. All right. Now, right here, instead of this being h approaches 0, we've now written everything in terms of the variable u down. So we have to look, as h approaches 0, what does u approach? And we could use this equation to figure that out. As h approaches 0, notice how as h approaches 0, this is going to become 1 minus 1, which is equal to 0. U will equal 0. So as h approaches 0, u will approach 0. And so we're just going to write that for our limit now. All right, u will approach 0. And this limit is still equal to 1. And so this is our limit, our new limit that we're going to solve after we've replaced the top part of this equation for u. This is what we have. Now you might be thinking, wait a minute, we technically didn't get rid of the number e. It's still technically in the logarithm because this is just log base e. But when we have natural log, if we were to rearrange this equation in some sort of way, it's possible that if we raise e to the power of both sides, e and the natural logarithm will cancel out, and on the right side of the equation, we'll get e as a limit. It's a possibility. So why not we just keep going with this and see how far we can go? Now, it turns out there's actually this really cool way in which we can figure out what limits are with logarithms. There's this technique that you'll learn. And so it's just that there's a pretty efficient way to figure out what limits are if we have logarithms. It's actually a really cool, pretty useful way. And so we're going to use that idea. And so what we need to do is we need to figure out how to take the limit of a logarithm here. But the first thing that we need to do is we should probably move this u with the logarithm. We want to move everything together with a logarithm. So we could bring this u down into the denominator right here. And the way that we could do that is we could say the u moves to the denominator, we make this 1 all over 1 over u, because that would be the same thing as u in the numerator. And then we still have natural log of 1 plus u, right? Is equal to 1. Okay? And I'm going to move over here. Actually, I don't know how much room we have. But anyways, no matter how much room we have, I'm going to move here because the next step is a little bit more work. And so what we can do is, since we now have a quotient right here, this is a quotient, we can say this is just the limit of this divided by the limit of this. Right? That idea for limits is what we're doing right here. So what we could say is the limit, I was about to write h, wasn't I? Supposed to write u, right? It's the limit as u approaches 0, not h. Right? Limit as u approaches 0 of 1 divided by the limit of the bottom thing, which is this, right? Right? So we pretty much said it's the limit of the top divided by the limit of the bottom. It's pretty much that idea for limits. And we know that the limit as u approaches 0 of 1 is still just going to be 1, right? It's not going to change the value of 1, so the top part is still going to be 1. And also, now that we're here, we can actually make this look a little bit simpler. If we take the reciprocal of both sides of this equation, well, the reciprocal of the left side of the equation is just going to be this, right? It's going to be what we have in the denominator. So it's going to be the reciprocal, so pretty much it's just going to be what we have inside the denominator. And when we take the reciprocal of the right side of the equation, it's still going to be 1 because the reciprocal of 1 is just 1. And so this makes it look a little bit nicer. Now, the whole idea of solving a limit with a logarithm is we got to get the limit and the logarithm next to each other. So we can do that because what we can do is we can move 1 over u into the logarithm using the logarithm power rule, right? The power rule for logarithms. We know we could say that 1 over u is just a power, it's an exponent inside the logarithm. So we could write it like that, where we say the limit as u approaches 0 of 1 plus u to the 1 over u is equal to 1. I forgot to write natural log, didn't I, right? The limit of the natural log of 1 plus u to the 1 over u equals 1. So I pretty much moved 1 over u to the power inside the logarithm. That's the logarithm power rule, right? So we've done that. Now we have the limit and the natural log next to each other. And so what we could actually do is we could say if this is the limit of the natural log of something, we could say that this is the natural log of the limit of that something. And the reason why is because this is just the idea of taking the limit of something composite. For example, the limit as x approaches a of f of g of x, we know that we could just rewrite this as f of the limit of g of x. That's the whole idea of pretty much the limit of a composite function. If the limit of f of g of x is equal to f of the limit of g of x. And so we could use this idea and apply it to here. And so what we could actually do is we could say this is the natural log of the limit of what was inside the logarithm. And so, yeah, that's the whole idea. So as you can see, that's what it is. So limit of that is equal to natural log of the limit of what we had inside the logarithm. Now we're almost done. All we have to do is raise e to the power of both sides of the equation. That cancels out, and we're left with e on the right side of the equation is equal to a limit. And so the limit, and this is it, the limit as u approaches 0, nope, that's not it. The limit as u approaches 0 of 1 plus u to the 1 over u is equal to e, because that's e to the power of 1. So this right here is the limit that is pretty much equal to e. And this is the limit that defines e right here. And so this is the whole idea. In fact, that's the whole idea. This right here is the limit that defines the number e. And this one's, it's commonly known, but another one is if you were to actually, like for example, if we said that m is equal to 1 over u, Okay, so this is u, but we're changing it to 1 over, all right, actually no. I'm gonna say that u is equal to 1 over m. So in that case, the limit would become, u would become 1 over m, so we get 1 plus 1 over m, and 1 over u would become m. And as u approaches 0, m has to approach infinity. And so this is also another definition for e, right? This would be another definition, another limit definition for the number e. So both of these would be valid. And so this right here is pretty much how we can write e as a limit, either one of these two ways. And that's pretty much it.